All right, today we're going to tackle one of humanity's oldest and most terrifying enemies, rabies. It's this relentless virus that goes straight for the central nervous system, and its whole terrifying reputation really boils down to one single, inescapable number.
That's right. Once you see symptoms, rabies is 99.9% fatal. I mean, think about that. There are almost no other diseases on the entire planet with that kind of kill rate. It's about as close to a perfect killer as nature has ever designed. And that's the big question, isn't it? If it's basically unstoppable once it gets going, how on earth have we managed to fight it at all? Well, as you're about to see, the secret isn't in fighting the disease itself. It's about stopping it dead in its tracks before it ever starts. So here's how we're going to break it all down. First, we'll get a sense of the global scale of this thing. Then, we're going to meet the virus up close and personal. We'll trace its path into the body, watch the damage it does, and then, the good part, we'll look at the incredible tools we have to shut it down completely. Okay, first things first, let's just establish the scale of this problem. Rabies isn't some dusty disease from the history books. Nope. It is a major, ongoing public health crisis, and it's found in over 150 countries right now. And this chart, wow, it really puts the human cost into perspective. Globally, about 55,000 people die from rabies every single year. Let that sink in. That's one person every 9 minutes. And you can see just how concentrated the problem is. India alone accounts for more than a third of that tragic number. That's a massive burden for one country to carry.
So if we're going to understand how to fight it, we've got to know our enemy. So let's meet the villain of our story, the rabies virus itself. The virus is part of a family called Rhabdoviridae, and what's really fascinating here is its shape. It's not a sphere or a blob like a lot of viruses. It has this very distinct kind of menacing bullet shape. And inside that shell, it carries its entire instruction manual on a single strand of RNA, which is basically the blueprint it uses to hijack a host's cells and make millions of copies of itself. Let's look even closer. This thing is tiny, just 180 nanometers long. But its most critical feature, its main weapon, are these little spikes that cover its surface. They're called Glycoprotein-G, and they are the key to everything. These spikes are perfectly designed to act like a key, fitting into specific locks on our nerve cells. This is how it literally picks the lock to our nervous system. But, and this is so important, these spikes are also its biggest weakness. They're the exact thing our immune system can learn to recognize and destroy. So, the virus has its weapon. How does it get close enough to use it? Well, rabies is a classic zoonotic disease. All that means is it lives in animals and jumps to humans. Let's see how that jump happens. Now get ready for this, because this statistic is just mind-blowing. We often think of rabies coming from wild animals, right? Like bats, raccoons, foxes. But look at this. For humans around the world, 99% of all rabies cases come from a single source, the bite of an infected dog. 99%. That tells you right away that vaccinating dogs is one of the most powerful things we can do to protect people. Now, a bite is by far the most common way, but it's not the only way. The virus can also get in if infected saliva gets into a cut or a scratch, or even on your eyes or mouth. And in some super rare cases, people have gotten it from inhaling the virus in the air, which is mostly a risk for people in labs, or tragically, through an organ transplant from a donor who had the virus and didn't know it. Okay, so the virus is in. From this moment, a clock starts ticking. But it's a really strange, really slow clock. This is the story of the virus's long, silent invasion of our nervous system. The time between the bite and when symptoms first show up, that's the incubation period, is all over the place. On average, it's about 1 to 3 months, but it can be as quick as a week. And in one absolutely insane documented case, it was as long as 19 years. Can you even imagine that? A virus just waiting inside someone's body for almost 2 decades before it strikes? So what's happening during that long, silent wait? Well, the virus isn't just hanging out. First, it sets up camp in the muscle tissue right at the bite wound and starts making copies of itself. Then, using those glycoprotein spikes, it latches onto the nearest nerve endings. From there, it begins this slow, steady climb up the nerves, like a mountain climber heading for the spinal cord. Once it hits that nerve superhighway, it's a quick ride straight up to the brain. And after it takes over the brain, it spreads back out, most importantly, into the salivary glands, so it's ready to jump to a new host. So, when the virus finally wins the race and takes over the central nervous system, the disease that follows can show up in two very different but equally horrifying ways.
About 80% of people get what's called furious rabies. This is the one we see in movies. Agitation, confusion, aggression, and it includes that famous symptom hydrophobia, the fear of water. But what's really happening is not a psychological fear. It's that the virus causes these intensely painful, violent muscle spasms in the throat whenever they try to swallow. The very sight of water can trigger it. The other 20% get paralytic rabies, where the muscles just slowly shut down, starting from the bite and spreading through the body.
Okay, I know. So far, this has been a really grim story. A relentless virus, a terrifying disease, and a near-certain fatal outcome. But right here, this is where the whole story flips on its head. Because while the disease is incurable, the infection is 100% preventable. Let's talk about that amazing defense. This quote really says it all. There is no cure. We can't treat the disease once it takes hold. Our only weapon is prevention, something called prophylaxis. It's our one and only chance, and it has to happen after you're exposed, but before any symptoms show up. And the World Health Organization has made the instructions incredibly clear. They call it post-exposure prophylaxis, or PEP, and it's broken down into 3 categories. Category I, an animal licks you, but your skin's not broken. Just wash it well, you're fine. Category 2, you get a minor scratch but no bleeding. Okay, you need to clean the wound and get the rabies vaccine. But Category 3, that's any bite that breaks the skin or any lick on broken skin, that requires the full court press. Wound care, the vaccine, and something called rabies immunoglobulin. Let's break down that Category 3 response, because it's truly a brilliant 3-pronged attack. Step 1, you immediately wash that wound with soap and water for a solid 15 minutes. That alone can wash away a ton of the virus. Step 2, you start a series of vaccine shots. This is what teaches your own immune system how to fight. But that takes a little time to kick in. So, step 3, and this is the genius part, you get an injection of something called rabies immunoglobulin, or RIG, right there at the wound site. These are basically pre-made antibodies that go to work instantly, fighting the virus on the front lines while your own body is getting its army ready. So, if you remember one thing, let it be this. Think of the virus as a lit fuse, slowly burning its way toward your brain. During that long incubation period, we have a 100% effective way to reach in and put that fuse out. But once the fuse reaches the dynamite, once the virus hits the brain and the disease begins, the explosion is unavoidable. We can stop the infection, but we cannot cure the disease. And that leaves us with one final, very tough question. If we have the tools to completely prevent this disease, if we've solved the science, then why are 55,000 people still dying from it every single year? It proves that the problem is no longer just about virology. It's a problem of economics, of awareness, and of access to healthcare. We have the solution. The challenge now is making sure it gets to every single person who needs it.